Hello everyone, welcome back to the second video on this channel, and today we're going to be talking about exoplanets. What are they, why they're important, and how we can find them. Uh, but first, as a table of contents, we're going to be talking about this week in astronomy, basically what happened. Then we're going to be talking about the exoplanets, and yep. So this week in astronomy, I'm planning on making this a weekly feature on the YouTube channel, in which we just talk about all the events that have transpired the past week relating to or of astronomy, astrophysics, stuff of that sort. Right, so first up is the James Webb Space Telescope and its various discoveries, achievements, observations over the past week. All right, so first is the Sears Epoch 1 color mosaic. It consists of 690 individual frames taken with the Webb's near-infrared camera called NIRCam. It's the largest galaxy survey image to date, and it views a field of view more than 8 times larger than the Webb's first deep field image. So if you think back to the very first image that was released by the James Webb Space Telescope team, this image actually looks at an area of space that is 8 times larger than that first image. So this is what it looks like. Astronomers have been able to find a lot, and I mean a lot, of new discoveries through this. A lot of really, really old galaxies, a lot of interesting, colliding galaxies, some interesting formations of galaxies, and whatnot. And so all these frames have been made up of, all these images are comprised of 690 frames in total, and they've been taken from the near-infrared camera in wavelengths ranging from anywhere between 750 nanometers to 600 nanometers in length. And so, believe it or not, one of these images actually discovers the oldest galaxy ever observed. Now, I don't know exactly how old this galaxy is. I think it's in the ballpark of somewhere like 13.1 billion to 12.9 billion years old. But this is the oldest galaxy ever observed, and over the next couple of months, we're going to be seeing bold assertions like this coming from the James Webb Telescope a lot, because there's been nothing like it. There's been no other telescope, there's been no other observatory quite with the magnitude of precision and observing clarity that the James Webb has. And so we're going to be seeing a lot of similar kinds of articles saying, oh, the James Webb found the oldest star or the farthest galaxy in the next couple of months. All right, so next up is the NGC 1365 close-up. The NGC 1365 is a galaxy. I don't think it's in any of the zodiac constellations, but the Webb took a close-up of the supermassive black hole region and ring at the center of the NGC 1365 galaxy. So basically, there's this inner ring that has a large population of black holes, and a lot of those black holes are orbiting each other, if not other stars, if not the quasar at the center of the galaxy. And this galaxy is 56.1 million years away. So these are what the images look like. I think that they're absolutely stunning. The black and white ones and the red one were taken by the James Webb. The red one was artificially colored, of course. And then the fourth image is actually a composite that shows you kind of like an overlay of what the James Webb took as compared to what the Hubble Space Telescope took of the same galaxy a couple of years earlier. And so there's just so much detail, there's so much precision going into each and every one of these photos. It's absolutely astounding. And so these are a couple more images that were taken by the Webb of the same object. The left image was taken by the midwave infrared instrument of the James Webb, and the right one is from NIRCam, which is, I believe, the near infrared wavelength instrument on the James Webb. All right, now finally, that wraps up this week in astronomy. And so today we're going to be talking about exoplanets, as mentioned. First of all, what are they? So most astronomers agree that exoplanets are planets from other solar systems other than that of Earth, and the closest exoplanets belong to the Alpha Centauri system, which is around 4.4 or 4.367 light years away from the Earth. They include, but aren't limited to, terrestrial planets like the Earth and Mars, Jovian planets like Jupiter and Saturn, dwarf planets, asteroids, meteoroids, and even moons. And this field in astronomy is currently experiencing a huge boom in research because of recent advances in technology and just more kind of public demand for more information, more study of the specific field. And so, how are they found? Most astronomers use two big methods, two major methods of discovering exoplanets. Those being the transit photometry method and the radial velocity method. So, transit photometry basically is based on the observations we can take of a transit, and a transit occurs when like an exoplanet travels directly between its host star and an observer on Earth, and when the planet passes between the star, it blocks a small amount of light that should have reached the observer, but instead isn't able to reach the observer because obviously the planet is blocking that light. And so with incredibly precise measurements, this small dip, and I mean very, very small, it's like to the hundreds of a percent dip in brightness, can be observed, and it can be used to determine the existence of an exoplanet. So this is basically what a transit looks like. As you can see, the planet kind of passes through between the observer and the star, and so when that happens, if we take a graph of the star's brightness on the y-axis and time on the x-axis, we can see this kind of dip in the brightness of the star. And so if we see enough of these dips at coherent time stops, it's a pretty big indication that there is in fact an exoplanet orbiting that particular star. And so this is what actual data from a transit looks like. As you can see, we have the apparent brightness of the star on the y-axis and the time measured in Earth days on the x-axis. And please take a note of the scaling of the graph. Usually you'd expect this graph to go from 0 to 100%, but in fact it's actually going from 99.2% to 100% of the star's brightness. And so that basically means that these transit block a incredibly small amount of the star's light, but with incredibly precise instruments like the James Webb Space Telescope or any other large telescope that we have here on Earth, astronomers are able to determine exactly how much light is blocked for exactly how much time, and through that information we can get to know the planet's composition, we can get to know the planet's volume, its mass, and even how far away it is from the star. And so because the exoplanets in question are so incredibly far away from the Earth, for a transit to be visible from the Earth, the planet must pass between its star and Earth at exactly a 90-degree angle. Even if it's passing at like an 89.99-degree angle, it won't be visible from the Earth because that light just isn't going to be directed towards the Earth. And so through sets of calculations, as I said earlier, observers can determine a planet's volume, the distance from its star, and even its atmospheric composition by using the transit method. And this is, I believe, the most common method for exoplanet discovery. Up next is the radial velocity method. This is, in my opinion, a more difficult method to undertake. And it depends on the gravitational pull a planet exerts on the star. And it studies the redshift and blueshift of the star's light due to this pushing and pulling of the planet. So using the radial velocity method, you can determine the mass and density of an exoplanet using this method. So this is just a brief diagram of what radial velocity actually looks like. And so the planet and the star both orbit around this one center of mass. And so when the star is moving when the star is moving away from the Earth due to the Doppler effect, which I will get more into in a later video, due to the Doppler effect, the star's light becomes a bit redder, and when it's moving towards the Earth, the star's light becomes a bit bluer. And so if observers are able to determine exactly how red and how blue the star's light can get, we're actually able to determine the mass of the planet, how far away it is, and like the density and the mineral composition of the planet itself, which is pretty cool. So here are just a few famous observatories that have been used to detect exoplanets in the past. These are all space telescopes. Obviously, we all know and love the Hubble Space Telescope. And the Kepler Space Telescope was launched in, I believe, 2004, and it reached the end of its mission somewhere around 2015, 2016. And this space telescope was only designed to detect exoplanets, and so it could detect using the transit photometry method and the radial velocity method, which is a really big benefit because if you use both methods on the same exoplanet, you can determine a whole lot about that planet, which you generally won't be able to determine by using just one of the two methods. The Spitzer Space Telescope is another one of the big four. This one's not as prominent as some of the other ones, but it's up there. And obviously the newcomer, the James Webb Space Telescope, the most precise instrument made by mankind. It's already observed like a lot of exoplanets. It's discovered, I believe, carbon dioxide in one of them using the transit photometry method just a couple of days back. And so right now, the field of exoplanet discovery is experiencing a really big boom because of these new advances in technology and also just more general public interest in the topic itself. And so why are they important? Obviously, why are they important? If we study exoplanets from star systems other than our own, we can have an inclination to find out how our own solar system behaves the way it does, how it was formed, the history of our solar system, and also habitability. Of course, somewhere in the near future, when humans inevitably make the Earth inhabitable, having a ready list of habitable exoplanets other than the Earth that humanity can travel to, no matter how rare that occurrence might be, would be a good idea just to keep the human race surviving and intact. And so that's about exoplanets. This is the end of the video. Thank you all so much for watching. Don't forget to like, comment, and subscribe, and I'll see you in the next video. Thanks.